more than one machine. We call it node, machine. Be familiar with these concepts. Try to be more familiar with these concepts. But what it does in its principle is just a component. It's just one computer that contributes to the solution out of a number of machines or nodes here, okay? Can run parallel because it has more of that. And we have a local, each one has a local operating system, but then they are interconnected through via a remote access network. And all of them are connected with one main computer. Okay, we talked about it. And then we said, what are the advantages and disadvantages? High performance, continuous. If one machine failed, the other one will still work, and you can add as much machines as you want. So it's scalable and cost effective. You don't need a supercomputer to run the whole thing. You can bring 3, 4, 10 of just normal, not super powerful, because they will work together and they will become powerful. So it's cheaper than compared to one computer that's powerful. The limitation was we need to put those physically, each one in one location, so it's centralized. Okay, and usually if something happened to them, you need to have your maintenance repairing unit, somebody that could come
При
and
этом
fix it for you, and it's usually not easy because each one will have its own specific network. It also needs fast communication between each other, and it uses a lot of energy. Okay, then we introduced and talked about grid computing. We say this is the user, okay, and you have more than one program, different program. For example, this is C++, this is .NET, and this is Java. And you pass your task, okay, that's why we put it this way. And you have something called control server. And you have another thing called grid nodes. What does that mean? Is these machines can be located anywhere in the world, and they can virtually get connected to one machine that's virtual, that's not real, and controlled by a server. Okay, we didn't go into the details. We will go into the details of this later on, but that's the idea. The idea is you have your machines sitting in different parts of the world. Not in the same geographic, not necessarily in the same geographic locations, because your master node is virtual, okay, and it's controlled by something called control server. That's how it works. And then we talked about it is advantages and disadvantages. So you can put anywhere in the world. It's decentralized. If a bunch of computers are working together in different parts of the world or different cities or different universities, this is called decentralized. It's highly scalable. Okay, so you can really increase the amount of computers that you have, as long as you don't have the main computer physical sitting somewhere. It's decentralized, so it means you can really increase the number of computers. Resource sharing, each computer can share resources with each other, can share its data. So this is really important because you need to have, this data should be protected, which data we want to share, which one we want to keep. It's another topic. It supports different systems, supports different operating system, as long as the main object is a bunch of computers that will perform one task, okay, together. So, for example, Mac OS can run a Python code, Windows can run it as well. If you have the same code and you want to run it, the same program, and you want to run it, you can absolutely use grid computing. But what are the cons? What are the disadvantages, the limitations or drawbacks? So we have more complex management. When it comes to manage between different operating system, right? Different programs, it becomes even more complex compared to the grid, to the cluster one. Security challenges, as I said, because it shares resources, it's subject to hacking. Okay, so you need to be careful what information you will want to share. It also needs, because you are putting more machines, and even in different parts of the world, how would they communicate through internet? So you will need a fast communication and fast, robust, powerful networks. These are the challenges. And by the way, these ones are, if you choose this path, you would be interested in focusing on one of these ones, one of these drawbacks, and how to improve it, okay, even further. Then we shifted our focus to something called utility computing. It's just the same as an architecture. It's the grid computing. But now we will talk about how it is being served. So the services, okay? So the services, it means how would you provide the service? Okay, it's more of like coming to the business part of the topic. So you will create a software that you provide services, and for every single service, you will have your resources. You will give you your resources, and you will charge them with some amount of money, like subscription or pay as you go, or you create your APIs if you are familiar with. So you will do it for them, for the customer, and in return, customer will pay for the service digitally. So grid service provider, you have two things. You can share your resources and you can share your software. Your resource, you can share the storage, for example. You can share things that they will pay for the resources, for the tools that you have. Okay. While the software is, they will pay for the application that you have. They will pay for Skype, for example. They will pay for premium, I don't know, any account that's premium. You pay for the service. But if you pay for the cloud, you pay for the resources, even though now it's really, that's also mixed. So, but you get the idea. Then you will have these services and tools set up and installed and built, developed in your corporation, company, and you just at the end of the day, you just provide the service, you get paid from the end user. Okay. So grid computing, we can summarize by saying that it is a coordinated distributed resources. It's used for large tasks, for tasks that are large, because we can use many computers. I am repeating this one more time because in later lectures when I come, you should absolutely know, and it's a little bit slow, so that's why please keep this in mind and try to not forget it. Okay. It's managed by different organizations. Grid computing focuses on resource collaboration and sharing, one that I just talked about. and it's usually without commercial billing. It's not available to public. They make money. You ask me, how do the payment? Yes, but for private uh, companies. A company like, we brought an example like Sberbank, okay, or any other bank, that they are really focused on their security and resource sharing. While utility computing is centralized resource management, they offer as a service, and it's pay as you go, and user are built. So this one
Available
is
on
open to
Windows.
the public. This one, grid computing, I did not show you the how the its service will come, but you can apply this to that as well. Okay, just know one of them is more to private companies, and it's usually much more expensive than this utility computing that provides service to end user. Okay, this is commercial. This is not really. It can be commercial in some areas, but more focused on the private sectors.
Capture.
All right, so we concluded and we said, let's give a definition of what cloud computing is. So cloud computing basically takes the nature, the architecture, the nature of grid computing, and mixes it with the easy access and commercial model of utility computing that will result in a flexible, scalable, and service-based solution. That's cloud computing. That if someone would ask you what is the cloud computing, you can tell them this one. If they dig more into then what is grid computing or utility computing, you should have a clear idea to answer them. Okay. Now let's go a little bit deeper into the cloud computing itself. We said cloud computing consists of, okay, we put it in a cloud. That's why they call it cloud computing. Um, it consists of servers. Servers, it means computers. You have it somewhere, okay? Virtual desktop, okay? A platform that you can access. Doesn't necessarily has to be the desktop of these servers, okay? And software platform, the interface of the software that they provide. Application, storage data. Servers, you have, let me give you an example. Let's say, if you know DigitalOcean, it provides the server services. If you don't know about it, I can make an example that you can understand. Let's say Google, okay? Google has its own servers, but Google provide a bunch of other services that you can pay for, okay? So let's say, for instance, you can subscribe to this Google Business or Google Suite. It's a platform that makes it easier for someone to do business. So when you go and you try to look at it, you see that they tell you that's our Google Suite. It's a virtual desktop. It's like this is our service. Okay, just inside you see what applications they have. Okay, their dashboard, it's software platform. Okay, and their individual applications are applications that you see, and things that you see if you use it, it's a storage data. So that's how they run their service. Okay, so you see everything, but it's not real. It's not there on the physical machine. It's based on the physical thing or their servers. You cannot access it. You can access it only through them, the amount that they give it to you. Okay. So, and you connect it through what? Through internet. And through internet, what if you go a little bit deeper? You either have a router that you have a mobile, you open Google, you got connected, you see their services, their platform, you subscribe for application, stored, you paid. So here you connected to the internet, your internet is a router, let's say it's at home or the university, and you are connected it through your mobile or through your laptop or even through your printer. Okay, straightforward. Or you have a bunch of computers in the laboratory, and you all can access specific services. The idea is just the same. Okay, so that's basically its architecture from the surface. Types of cloud computing, we have two main things. The first one is based on deployment, the other one is based on service model. We will talk about this a little bit more in details. So let's talk about the deployment. So what is it based on deployment? You have three main deployments. You have private, public, and hybrid. Let's just open it. So private cloud is what? So dedicated to a single organization. You want to have a cloud for your university. You can buy it, okay? It's only for you, private. Managed internally with full control. They give you full access. Don't confuse. This is not the one that we say commercially not available. This one is your data still will sit on their servers, but they give you the service. They dedicate for you a portion of their machines just to you privately, okay? And you can access it through internet. Managed internally with full security and customization. They give you full control. They have, high security firewalls. You see, that's not easy to hack. That's very robust and secure. The disadvantage, as you might know, it will be much harder to maintain and to manage the whole, because now they give you full control and now you need to understand how it works. You need to hire employees to manage it. On top of them, you need to hire engineer that will create for you the architecture, and all of this they cost, and it's a lot. And if you want to be that person, it's possible. It's a highly paid salary that you want to manage, but it's intense. It's not easy. It's complex, but you can choose that path. The way to go is to go to for example, a company, a bank, most likely a bank, and say, okay, I have skills in managing the architecture of cloud computing or maintain, and you can apply and you can be hired. So large banking using cloud computing, and even you will have the employees that are managing it. So it's a whole department everywhere, almost everywhere that uses the cloud service. Not almost everybody will have the maintenance person or department or entity or whatever you want to call it, someone who's maintaining it for them internally. All right, then we have cloud public cloud based on deployment. Okay, that the previous one was private. Now this is a public. So these companies who are providing the services, at the beginning they were just providing for private companies. Now they said, okay, let's just provide this service to anyone. Maybe someone has an idea. Maybe someone will do a startup. Maybe someone will just want personally to learn. So they made it public. What does that mean? I think someone came. But this will be whoever came. It's a little bit late this time. I'm letting you next time, um, try to come on time. Okay, so that's the public service offered by third-party providers over the internet. You pay for your subscription, and you don't need any management, because if there's an error, a mistake with the service that you bought, that you ordered, subscribe to, you can just get in touch with their team, and they will guide you through, and they will help you. Okay, it's cost saving, easy, and have scalability. Okay, but it is limited. For example, some companies, they use Amazon Web Service on top of their private, or Microsoft Azure for web hosting. These are two main examples. Okay. Then we have something called hybrid. It's they have both. So it combines both private and public cloud features. As the first point, it's a mixture of both. Okay, flexible workload shifts between private and public cloud. Let's another time. Let's bring the Sberbank example. Um, Obviously, Sberbank is rich. Why? Because they have the private one and they have the public one. How do I know they have private one? Because all their records are sitting on their own cloud, and they have a team who are managing it. Okay. At the same time, when you go to their application, you can subscribe to certain specific features, and you have the service that can answer you in case of any mistakes, right? So they have two, they have both, so it's mixed. Okay, best for both worlds. You can pay, or you can just have the main, you can just have the card, or you can just pay for their services as well. So they provide both. But this is obviously you need a much bigger team in order to control the whole thing. If an error happened internally, you should have your people. And if your subscriptions that you subscribe, you should expect from your users, if you have an error, if there's an error or a problem, you something called customer service. You need to answer fast to your customers. Some customers would come and talk to you the way that you might not like, but you still will need to be nice. You need, because you are providing a service. Regardless how your customers are and what kind of issues they have, you need to be fast for solving the problem. You need to answer them the way that they want, not you want, the way that your customer wants. So it's intense. It's very intense. And healthcare is another example. Company storing sensitive data in a private cloud, but using the public cloud for less critical tasks. For just a normal diagnosis can be public, but more personal, in-depth user data, because a patient will need, I don't know, a passport number, his IDs, and other things that are sensitive. Okay. All right, so that's private, public, and hybrid based on deployment. So we have something else. Please pay attention to this one, as you would see all over the internet, these names, and you need to be aware, and you need to know, you need to be aware enough of what are they, what do they stand for. Okay, so the first one, based on deployment, they will deploy it for you. They will install it for you, set up it for you. Now, based on service model. So what is service model? Okay, the first one is infrastructure as a service. So IaaS, it's called infrastructure as a service. Let's take a look and see what is it. It provides servers, storage, and networking via a virtual interface. It will provide you virtual, not real, servers if you need, storage, cloud, how many gigabyte, terabyte they will provide you, and they will provide you a simple dashboard that you can control. Users control applications, storage, and operating systems. So you as a user, you can control the cloud itself, the storage, the operating system that are running on it, but virtually. Okay, so it's more than that. It's not just they set up for you and you can just, they give you the whole package, but it's not, it's virtual. Okay, and the vendor manages hardware and infrastructures. So you can't really, it will look that you have an operating system like in Amazon, but this operating system in its principle, it's there. Okay, it's the hardware and it's there, it's not yours, but they are giving you virtually, they are giving you, which is the same thing as physically, except it's not yours. Okay, you can run your code, you can run whatever you want, but it's not yours. Examples of those: when you rent, literally when you rent virtual machines through AWS EC2, it's very famous, and you are a person who has a computer that's not fast enough to deploy your machine learning model, for example, or you're running Mac OS, you need to run Ubuntu, for example, and you don't really have time to do that. Of course, you can install a virtual operating system on your computer. If this is not an option and you want an easy option and you want a very powerful virtual machine, you can rent it. Okay, you can rent it from Amazon. It's just an example. There are other services as well. So this is called infrastructure as a service. So you rent the whole machine that has everything you see on your computer that they also has it. Okay, the second one is platform as a service. So PaaS, development and deployment environment. In the cloud, users focus on apps while the vendor manages infrastructure, pay as you go. This is almost the same as the previous one, plus what they do. They will have the application set up. They will manage it for you, okay? So if you don't have time and you have money to pay, you won't even have your computer just flat, just nothing on it. Things are installed, your applications are installed, so more services are installed. As a platform as a service, they give you the whole platform. Okay. Examples of this: Google App Engine for developing and running web app. If you are familiar with Google App Engine, it's a whole engine on a server, on a machine that you don't need to install. You just will have to just work on it. You can just work on it directly to build your beautiful web applications, and you don't need anything. All the libraries and things are installed, and the whole engine is there for you. Okay. The third type is SaaS. You might have heard this one a lot if you search for cloud computing, or even if you go through I don't know, YouTube or anywhere. You could see when you search for anything close to cloud computing, or how to develop digital software, this type of work, you probably will come across something called SaaS. It's software as a service. So This one, access vendor software on subscription basis. No need for installation. Access via web. Vendor handles hardware, software, and security. You, as a developer, will develop a service. Will develop image recognition that can, let's say, for instance, if one of the core applications would be, you develop a software that you tell, look, you can upload any image and I will find, I know there are such services out there, but I can, your image, I can find it on the internet, the same image, and I can bring it for you. So you will develop your web and you will develop everything for the user. You will tell the user, you will just need to upload your image and hit run and you will get the results. But you have to pay every month. You have to pay 1,000 rubles, for example. Okay, so this is called software as a service. The user will not do anything. He will just use it. He doesn't have any hardware. Also, he just has his own computer and the internet, and the money to pay for. Okay, so you will handle its own subscription basis. For example, you can say, okay, pay as you go. Look, one image will cost you, I don't know, 50 cents, something like that. He doesn't need any installation because you set up the whole thing, and all hardware and software, everything is secured. He will just need to use it. And this is the type of business that a good number of people in tech are doing. They provide a service, they provide a software service, okay? Because you can do that. You as an individual, you as a student, you absolutely can do that. You can create a website that provides a service, and you can tell people, pay more for my service, you will get my service monthly, pay this amount of money, and this is absolutely possible. An example is Salesforce, the British Salesforce. This is very, very big. They provide this same, but we can bring many, many, many examples. I don't know, even the entertaining, let's say Netflix. You pay for the Netflix and they in return, they provide you the similar one, the similar Russian one. I don't know the name, but it's similar. You just pay for the service and you get it. And Google Workspace, this is important if you have your business tied to Google. You are managing your employees. You give them an account that's based on Google accounts. You would want to subscribe for Google Workspace to manage your own business. Okay, so this is something interesting to think about, and this is the most achievable one for you if you are on a budget, you don't have money, you just want to develop something and bring it to the market, by the way, internationally. So okay, so we knew all these three. Okay, all these ones. We will just go to the challenges. What are the challenges is it clear so far? Someone can say yes if someone has access to his mic. Can't hear you. Okay. All right. Sorry. So, okay. So it's centralized processing. Large data center can create bottlenecks, slowing time sensitive tasks. If you have I don't know, a service that you are video streaming service, many people came into it. It can slow down the service, so it's a challenge. Latency issues impact real decision making. These are some of the challenges, and it's very interesting to focus on these challenges and try to solve it. So if you have a company and you don't have a good team that would manage your servers, your service, your deployment, disaster management system, I will need immediate response because people are paying for it, people are using it. So you will try to have a very good team of engineers that would make it smooth, the service. All right. Now discussions. I want to discuss with you. I think until here you got a very clear idea of what cloud computing is. If you don't, still something is not clear, please look at the slides. I think they are quite straightforward. And based on that, what I will be doing is I will send you a form, okay, which you will give me a little bit more about how you want to go, okay? And we will discuss about it and we will decide how this lecture can move forward, okay? How can we move forward with this, with the path of the lecture, okay? So the first point that of the discussion that I want to discuss with you is about, are you more towards theory or practice? If you tell me we do both throughout the year, I don't know if we can make it completely to do theory and practice completely 100%. And I want to give you something that's end to end, that by the end of the semester, you should have a clear understanding of cloud computing, plus you should move forward and use it in your future work if you are interested. Okay, so we will talk, of course, now theoretical. It's theoretical. We can talk more about it, but what the discussion will be, if you want to more focus more on theory or practical applications that are out there. That's the first point. The second one is projects or papers. Are you more interested on publishing papers? By the way, we can talk like we do both, but are you more interested in hand-to-hand project?
Omar, Omar, check chat, please.
I will check the chat list. Okay. I will answer all these questions. Is it okay? But I really encourage you to talk because each time you see, I will have to switch. So I encourage you to talk. I will come to your chat list and I will answer it. Let's answer this one. Is Google Colab PaaS or SaaS? Okay. On one hand, it's fully turned on platform. Okay. But on the other hand, it provides us only the language. Yes. Google Colab that you work on at the moment, it's considered software as a service. But if you dig deep into it, there are companies that are deploying it. So it can be for you. In your case, what you see is SaaS because you are using their service. They have everything, all the libraries installed for you. You are just using it, and the whole thing is set up for you. And even you can ask them questions. Absolutely, programming language. You mean the programming language is just a service on the software that they have installed on their machines, and they are providing you with the IDE that's Colab, and everything is installed. No, it provides also computing unit You need to think of the service. It's not if you have a company, okay? If you have a company, I'm sorry. If you have a okay, so platform as a service, it's the service itself. So you need to some sort of deployment in the cloud. You need to have something, not just access it directly, okay? And users focus on apps while so you focus on the specific apps that you have, while Google will manage its infrastructure for you, and you pay as you go for what? For the cloud resources. I know you can add. I totally agree with you, but the collab that you see as a package that you see is a service, is a software service, because everything, because look, they provide for you, they manage for you, the hardware, software, they manage for you the units, they manage for you everything. You don't need any installation in that case, okay? So when you try to do your startup, okay, or when you try to do your own uh, service, then you should focus on the platform as a service, okay, your own platform. This is public. Collab is public, okay? But good question. Take a look at it. I want you to bring me more used cases of platform as a service and software as a service, okay? Cool. All right. Any questions, guys? Any questions you have, please, I will share with you one section for the questions, and feel free to ask, and I will answer them the next lecture. So you have more questions, please ask. I will answer them when it comes to the commercial services out there in the market. I will be happy to answer. Please feel for me in the list, and I will answer them for each time for the next lecture, so we save time. So good. Theory and or practice, we said, projects or papers, okay? And so projects, so you want the project or you want the research paper, you want at the end to publish a paper in the academic, or you want a project that maybe it's potential, okay, that would go to the market. Maybe not, look, maybe not, maybe yes, maybe not. But even if it's maybe not, it's potential. It will help you to go to the market, but maybe it will take more time. On the other hand, you have the research paper, how to write the research paper, abstract, and all of this, and boost your academic portfolio. And I'm not saying it's bad at all. I have a number of research out there published. It's not bad, okay? Projects. So this one or that one, which one is more relates to you? All right, so third point, case studies or simulations. So you want the real world case studies, have to bear in mind it's more complex. Or you want we go more to a lab simulations, just create something fun and play with. We can work on something, okay? But I will need you personally to give me an answer. Okay, so number 4, you guys want individual, each person work alone or collaborative in groups? Maybe someone will someone will say, look, I want to be individual, I want to work on my own thing. And the other will say, okay, we are 3 people, we are 3 colleagues, we want to work on something, on a project or a research paper, by the way. So which one you think you want, or if you think you can be in a group, list your names. We want to be in a group. But I want to tell you that try to pick a team. If you want to go individual, it's completely fine. That's it. It's understood. If you want to be in the group, you really need to know the other person, not just because you will work together. And this is something really important. At the beginning, colleagues, they say we will work together, then they can't work together. Okay, here try to observe your colleague. He's your friend, completely fine. We are friends. We go outside. We play football. We do all of this. It's really good. But when it comes to work, try to pick somebody that are mind-like. Okay, that you, and not someone that you say, okay, this one is much smarter. No, it's not related. It's not connected to that per se. It's connected of whether are you able to work with that person or not. Because let's say if you pick a group and you work for 2 months on something, and then for some reason that colleague or that collaborator, it was not a good fit, and you got tensions, problems, it all goes away. Your decisions now in the beginning can shape your future. Okay, so try to, and along the way, you guys can change the idea. Along the way, how you build a project can change. Absolutely. Along the way, some other people maybe can come, but to start, you really need to. I'm talking about 2%. If three is completely, it will be even better. But try to pick a person that you can work with. That will not forcing you. You are not forcing him. That you guys are working, can work together. Just that. Okay. If you decided to do a group work, and this will be my suggestion. Okay. All right. The other point that I want to discuss with you about, and all of that, look, as I said, I will send you a form, and you can fill that, and we can discuss about it. We can make it public. Everyone will see what the other person has said or want, or we can make it private. Each one of you would want to have its own privacy, has its own thing. It's completely fine. So we will know about that. Then number 5, in my opinion, is the most important one among those, is you want the industry or academic focus. What does that mean? You want us to explore the industry? We can, I can request, okay, to ask Letty if you guys want the industry. You want to see on the market in St. Petersburg, let's say, uh, uh, what are the companies that are doing cloud computing, and you really want to visit, right? You want to take a look at the industry by your eye, and see what's happening and experience that. I can request. I cannot guarantee you that it will happen, but I can request, and I think it's possible. Okay, so you go and pay a visit and see what's happening, and maybe visit a number of companies, big companies, small businesses, big businesses, you name it. We pinpoint, and we go and see, and you see it by your eyes, and you see if this is something for you, if you are into this. Or academic concepts, if we want to then ask Letty, have another request, or have a request to Letty to say, okay, can you connect us with the universities, uh, uh, educational entities that have this kind of workshops, and so academically connect us to have more in-depth theoretical or education related knowledge. Okay, so it's two, because look, it doesn't matter how much I explain to you, if you don't see it, you don't get it. So you would need to know how far you are from this, how much close you are into this thing. Okay. Lastly, so that's important. I will share this with you. Please, we will have a platform. We will share the ideas, these points, and I will see the majority. Okay.